Hi, welcome to our new unit, which is System of Equations and Inequalities. Today's lesson, we will be talking about graphing systems and also reading graphs when it's dealing with systems. So the objective is, how do we solve systems of equation by graphing? So in order to know what systems of equations are, we need to know the definition. So it's two equations graphed together on the same coordinate plane. So you have two equations, plot them, and you see what they're doing between the both of them. Solution of a system is an ordered pair that satisfy both equations. So when you look on a graph, you're going to see how the two lines interact with each other. So where they intersect will tell you what is the solution that they both share in common. When it comes to systems, there is two types of system. There's consistent system and there's inconsistent. Consistent system is broken down into two different factors. But consistent system is called a system with at least one ordered pair that satisfy both equations. Consistent equations are independent or dependent. So with the independent, that means there's only one solution for those two lines. So that's where they meet. And with independent, it's an infinite number of solutions. Basically, it's line on top of a line on top of a line. It's the same line, but they're sharing common points between the both of them. We're going to see pictures of that just so we can understand what's going on. Inconsistent systems is a system with no ordered pairs that satisfy both equations. So when it comes to that type of system, it's usually parallel lines. Parallel lines is connected, inconsistent systems is connected to parallel lines. Again, we will see diagrams that is related with that. And as stated, inconsistent graphs are parallel lines. So here's a table showing all the systems that we just talked about. When you have two intersecting lines, the number of solution is only one because it's where they intersect. Where they intersect, that's the solution. And when it comes to the terminology, what type of system are we dealing with? It's a consistent system and it's independent. So in order to remember and understand what is going on, you have two lines. Two lines, they're doing their own independent things, they're going in their own directions, doing whatever they have to do. But they're consistent, meaning that they are going to share a certain point. They're going to share like a certain view that will make them consistent. So think about like you and your friend doing your own thing. You have your own personalities. You do one thing one way, they do another thing another way. But then there's something that you have, either like at least one thing that you have in common where you could agree on and try to work with that. So that is what consistent and independent is. So like independent, you and your friend are independent, but you have one thing in common. So you make it consistent. When it comes to the same line, you'll have equations, they'll have the same slope, they'll have the same y-intercept, but they're just on top of each other, but you don't see that, but there's one line and they form as one big line that share all the points. So when it comes to the solution, whatever point you choose on either line, they're both going to have it. So it's infinitely many. And when it comes to determine what type of system it is, it's consistent. Think about it. If you and your friends, you're making money, but you want to buy something and it costs a lot, but if you put your money together, you work as a group and put your money together, you'll have enough and get the money up front quickly and have a lot of it in order to get whatever you would like to get. So you're both consistent, you're both on the same page, have the same goal. So consistent, just like the lines on top of the other lines. And it's dependent. Independent because without, for example, with your friends, without your friend, you are dependent on what they make and they're dependent on what you make, so you can combine it to get what you need to get together. So that's how the same line works. They have infinitely many solutions, and they're going to be consistent because they got the same goal, and they're dependent on each other. With parallel lines, as you can see, they're both running in the same direction, but they'll never intersect, they'll never meet. That means there's no solution. Whereas with intersecting line, they're going to meet at a common point. With parallel lines, they'll never have a solution, and it's inconsistent. That's the only graph where inconsistent system, that option is used, when it's a parallel line. So again, using an example of you and your friend, you're both going in the same path, doing the same thing, but you're never going to, you may say like you're doing what you got to do. You're both like you're independent, but you're doing the same thing. You're going the same path, following the same course, like if you're in school, but your friend is doing or solving things in one way and you're solving it another way. But the problem is you both don't agree on how to solve the problem, even though you end up in the same path. So that makes you guys inconsistent because you'll never agree on one thing, but you're going to do your own thing and just keep on following the same course. So that's what parallel lines, they're inconsistent, there's no solution. All right. So with we have different types of graphs at the bottom here, and it shows the different there's 4 graphs, and they have the different 4 different or 5 different equations. So for the first one, if you look at the 2 equations, so we got x, negative x plus 5, and then we have x minus 3. If you look at those 2, so look at what they're doing. This is this line, and then we have this line. Let me lock this so that way it doesn't move. All right, so we have this line, and then we have this line. Notice how they intersect at a point, and that point is 1, 2, 3, 4, 4, 1. So that means they intersect at one solution. So again, they're telling you, is it no solution, one solution, or infinite solutions? So you're going to have problems like that, you have to determine. So that means there's one solution. That's where they intersect. Example 2, we have these 2 lines. We have y equals negative x plus 5, and we have 2x plus 2y equals negative 8. So let's look at these 2 lines. We have this line, and we have this line. So they're both running in the same direction. If you were to change this, so this is y equals whatever it is, so I'm going to do that so that way I can show you exactly that they are parallel, because we have to prove that. So I'm taking this one, and I'm going to solve for y. So that means I'm subtracting 2x on both sides, and then I'm going to divide 2 on both sides, and then this will give me y equals negative x minus 4. So notice how they have the same slope? Ding, ding, ding. If it's the same slope, then the lines are parallel. So yes, it's parallel. They're parallel. So when it's parallel, they'll never intersect. They'll never meet at a point. That means there'll be no solution between the 2 of them, and it's inconsistent. So remember, parallel, inconsistent is always attached to parallel lines. And then the last one, 2x plus 2y equals negative 8. And then we have y equals negative x minus 4. So remember how I turned this into the y equals mx plus b, the slope-intercept form? How it gives me y equals negative x minus 4. This is also negative x minus 4. So I'm going to write that so that way you'll know, okay, or y equals negative x minus 4. So notice that they're the same line. So if they're the same line, it's going to be one on top of the other. But to select, so that's that same line. Notice how the bubble is pointing to that line. So when you have the same line on top of another, on top of top and top, they have lots of points between the 2. So it's infinitely many solutions between those 2 points, the two lines. All right, so those are the 3 types of solutions. There's one solution, there's no solution, and infinite. One solution means that 2 lines intersect at a point. No solution means the lines are parallel, they'll never meet. And infinitely many solutions, that means you have the same line on top of each other. Okay, so we're going to do examples based on reading systems graph. So they're going to give you a graph, they already have the line, and any information that's needed. So in order to know what's going on, they might ask you like how many solutions there are, what type of system, if it's consistent, inconsistent, dependent, or independent. So based on what we just learned a few minutes ago, we're going to apply it to this problem. So I'm going to take okay. So for the first one, this says red line. So I'm looking at the red line. We need to know what the slope is. Again, you've done this before where you look at a graph and you have to figure out what the equation of the line is. Because the only way for us to know what type of system, I mean, yeah, we can look at it from the graph, but we also need some other information to just back our answers up. So look at the red line, let's look at the M. So actually, you know what? Let me use red. So they already have a point here. I'm going to find another one that is in the intersection of the two axes. All right, so then I'm going to go down 1, 2, 3, 4. So -4 over 1, 2. Rise over run. And then that's the same as -2. My B, this line is hidden, even though it hasn't passed through, but it's touching it, it's 7. All right, so my equation of a line, you remember y equals mx plus b. So it's y equals -2x plus 7. So that's the equation for the red line. Now let's look at the blue line. The blue line, the M, I'm going to find a point where the two axes intersect right here. So I go 1 down, and then I go 2 to the -2 to the left. So it's -1 over -2, which is also the same as 1 over 2. Then my B is where the blue line hits the y-axis, which is at -3. Not 3 because negative is down here below the x-axis and positive is above. So my equation of the line is y equals half x minus 3. All right, so I got my two lines. Now they say the point of intersection. I'll use purple for that. My point of intersection is going to be a coordinate point. So where they intersect, all right, they're right there, intersect. So it's 4, -1. So 4, -1. Next question is how many solutions? You could clearly see that there's one solution. So one solution because they intersect at one point. What type of system? Is it consistent or inconsistent? All right, so let's think about it. We know that inconsistent deals with parallel lines. These are not parallel lines. So that means it's consistent because they have two lines, even though they're doing what they have to do, they're going to meet at a certain point, at a common interest. So they're going to be consistent. So I'm going to write consistent. And then the next one is dependent or independent. Well, again, you got two lines going in their own different direction, but they meet at one point, but they're independent. Because dependent, that means they would be on top of each other. The one is dependent on the points of the other and vice versa. So this one is independent because they're doing their own thing, but they'll eventually meet at one point where they agree on something or they share a point. Okay, so that's how you would do that, by reading a graph like this. And right away you would look at it, you'd say, okay, it's one solution, you would say it's consistent or independent. But I went extra further to show you what's going on with these two lines, what type of lines are they, then write the equation. And if you look at the equation for both of the line, the red and the blue line, notice what's going on with the slope. One of them is negative, one of them is positive. One of them is 2 over 1, or 2, and the other one is 1 over 2. Remember about parallel and perpendicular lines? Perpendicular lines is opposite reciprocal. So you know what I'm going to write? I'm going to write perpendicular lines just as a review. So perpendicular line. And because they're perpendicular line, they form a right angle, which is 90 degrees. Okay. again, this is reading the graph. You have all the information that's needed. You come up with your solutions for each part, and then you can actually dissect a graph like that. All right, let's do another one. So right away, we know it's two parallel lines. But again, you can't assume, because the only way to say that these two lines are parallel, we have to look at their slope. So I'm going to find the equation for each of the line. So for this one, the M, I'm going to find 2 points where it intersects at the y-axis. So this one and this one. So I'm going to go, to get from this point to this point, I'm going 1, 2, 3, 4, 4 down. And then how many to the right? 1, 2. So that's -2. And the B, it's at, this is -1, -2, and that's -3. All right, so now I got that, and then the equation of the line is going to be y equals -2x minus 3. That's for the red line. For the blue line, I'm going to do the same thing. Let me see. I find this point, and then this one is sitting on this line. All right, so the M, going 1, 2, 2 down, and then 1 to the right, and that's also -2. Oh, look what I'm seeing. And then I'm going to put, this is 3. I notice that the slopes did the same, so right away I know that, yes, those two lines are parallel. All right, so since they're parallel, is there any point of intersection? No. I'm going to put none. None. And I'm just going to put parallel lines. Because parallel lines never meet. They're never going to have a solution. How many solutions? 0. 0 solution. What type of system is it? Remember, with parallel lines, it's always connected to inconsistent, because they'll never agree on anything. They'll never meet. So there's no corresponding with one or the other. So inconsistent. Dependent or independent? Neither. When it comes to inconsistent systems, the graphs, it's not dependent, it's not independent. They're not dependent on each other. They're not not independent. Okay, and if it's independent, the reason why, because yeah, they're doing their own thing, but the thing is, the reason why they're not independent, because they're going in the same direction. It's almost like if your friend is doing one thing and you copy, like, oh, I'm gonna be over here, but I'm gonna do the same thing my friend's doing. So you're not really being independent. You're basically copying off on a person. So that's the way parallel lines operate. Okay. Now we're going to graph the system of equations. We studied it, we read it, now we're going to graph. So let me make this smaller. All right, so they want us to find the solution to the equations by graphing. So the first thing we're going to do, they gave us two equations. We're going to find the M and the B, because in order to graph, we need the slope and we need the y-intercept. So the slope, it's -1. I'm going to put -1/1 because we're going to graph it. And B is +8. So let's find our 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we go 1 down and 1 to the right. 1 down, 1 to the right. And I'm going to go opposite of 1 down and 1 to the right is 1 up and 1 to the left. And then I'm going to graph that afterwards. Actually, yeah, I'm going to graph that afterwards because I have to change screens. So I'm going to go to the red one, the red line. So the slope is 4. I'm going to put 4/1 because we're going to graph it. And then the B is -7. So we look for 7, -7, 1, 2, 3, 4, 5, 6, 7. And then we're going to go 4 up, 1, 2, 3, 4, and 1 to the right. 4 up, 1, 2, 3, 4, and 1 to the right. Okay, so now I'm going to go back to the other screen, and I'm going to get my lines, going back to that so I can have the red line and a blue line, so that way I can distinguish between the two. All right, we have this. sure it lines up, and then the blue line, oops, oh, let me do that again, oops, go back to that, and then choose the line again. Okay, so that's good, and then blue. All right. Okay, the full screen, and then what I'm going to do is I'm going to label my line. This one's y equals negative x plus negative x plus 8, and the other one is y equals 4x minus 7. Get into the habit of labeling your lines, because now we're not only working with one line, we're working with two. And if you just give me two lines, I'm not going to sit there and figure out which line is what. And I'm going to literally write, especially if it's on your test or homework, I'm going to put what line is what. I'm going to continuously do that until it gets annoying. So always get into the habit of labeling your lines. So now let's find the point where they meet. So it's right here. And then it says how many solution? There's one, because they intersect at one point. And that solution is, you don't need to, it doesn't tell you, but I'm just going to write it. 1, 2, 3, 1, 2, 3, 4, 5. So it's 3, 5 is where they meet. And is it consistent or inconsistent? It's consistent because they are agreeing upon one thing. It's at one point. And is it dependent or independent? It's independent because they're coming from different locations, but they're coming to one point where they have something in common, and then they go off onto their own way. All right, let's do another one. So we have two equations. Again, we're going to do the same thing, but this is different from the other one that we did. We have to turn it into y equals mx plus b. So that means y has to be by itself. We subtract x on both sides. The 2y. And then we divide. And it's going to be y equals negative half x plus 5 over 2. And 5 over 2, oops, 5 over 2 is 2.5, just to remember that. So our m is negative half, and our slope is, our y-intercept is 5 over 2, or you can just put 2.5. And then for the blue line, we need to turn it into y equals mx plus b. So then that means we subtract 2x on both sides. And then we get 4y, and then negative 2x plus 2. Divide 4 on both sides. And then we get y equals negative half x. It's 2 over 4, but when you reduce the fraction, it's a half. And then that's also going to reduce to a half. So our m is negative 2, 1 over 2, and then we have our b at a half, or that's also 0.5. Notice that we have the same slope, so we know that it's going to be a parallel line. So first thing, let me go back to the red pen. I'm going to put my b, which is at 2.5, so 2.5 is there. So then it's 1 down, and 2. 1 down, 1 down and 2. I know I could do more, but I have enough to make my line. And then the other one is also at, oops, that's supposed to be, oh, what did I do? Oh yeah, I did it right. Never mind. So 0.5, so 0.5 is here, and I'm going, and then I forgot the minus, that's right. 1 down, and then 2 here, 1 down, and 2 here. All right, so I'm going to go back to the screen and go to my line. I'm going to use the blue just to show the parallel lines, and then red. Oh, what am I doing? Go back to that. sure I have the color red. All right. All right, and then go back to the full screen. All right, so I'm going to, when I label it, I'm using what I started off with, and then the blue. This is 2x plus 4y equals 2. All right, so now we can answer the question. So we know that there's no solution, none, because they're parallel. Consistent, inconsistent, we know it's inconsistent. Anytime you're dealing with parallel lines, it's inconsistent. And neither. It's neither dependent or independent. All right, and let's do one more. So one more, we have to change this into y equals mx plus b. So this one will be negative. We subtract a negative x on both sides. So negative 2y, negative 2x, negative x, negative 2, divided by negative 2. So that's y equals 1/2, because the negative divided by negative is positive, and then this one will be positive 1. Our m is 1/2, and our b is 1. And I'm just going to plot it on the graph. Got 1, so go 1 up and 2, 1 up and 2, and the opposite, 1 down and 2 to the right, 2 to the left. And then I'm going to do the blue one. Again, I'm going to subtract 4x on both sides. And then I have negative 8. And then I have negative 4x. And divide by negative 8. And negative 4 divided by negative 8 is going to be 4 over 8. When you reduce it, you get 1 over 2. X, and then negative 8 divided by negative 8 is positive 1. And again, 1/2 for the slope and 1 for the y-intercept. And again, notice how same points, so same line. So I'm going to go back to the line. Let's see which one comes up. Oh, red comes up first. And then I'm going to put the blue one. It's also going to be the same line. I'm just showing you. Okay, yeah, that's right. So I'm showing you how that they're going to be on top of each other, but I'm just showing you that it's both lines. So again, I'm just going to label it. So this one is x minus 2y negative 2, and the other one is the 4x minus 8y equals negative 8. How many solutions? They're both shown on the same line, so it's infinitely many solutions. And I'm just going to put the word infinite. And consistent or inconsistent? It's consistent because they're sharing points between the two. And they're dependent on each other because one needs the other line's points and vice versa. Okay. See we yep, good. All right, so we're just going to do a recap. Go back. Whoops, too far back. So we learned about system of equations. Basically, it's two lines, and you've seen what's going on between the two when you graph them. And when it comes to that, you have consistent, and the solution of system is, solution of a system, it depends on what the lines are doing. Will they be a solution? Will there be any solution? Or will there be many solutions? And consistent, there's consistent and inconsistent. Consistent is broken down to dependent and independent. So independent means there's only one solution. Independent means that there's many solutions, infinitely many solutions. And inconsistent means there's no solution at all. And parallel lines are the only type of graphs where there's inconsistent system. And when it comes to, again, looking at the graph, you look at what the lines are doing. Again, one point, one solution. Parallel, no solution, inconsistent, and infinitely many solutions is dependent and consistent. And again, read in the graph, look at the lines, look at the equation of the lines. For example, we notice that this is going to be perpendicular. Even though they didn't ask, but you can see by looking at the slope, find the point of intersection, and determine what type of system is it based on what's going on in the graph. So we looked at two different solutions, where they intersect and where they're parallel. And with graphing, same thing that you learn when it comes to graphing just a singular equation. Find what's the m, what's the b. Put your b first. B is where you begin. That's your y-intercept. And then use the m as your direction, as your slope. Once you have the two lines, see what they're doing, and then answer the questions based off of that. So we did three different types where they intersect at one point. They don't intersect, so they're basically parallel, and because the slope is the same. And where the slopes are the same, the y-intercept is the same, that means they are on top of each other, and that means that they're dependent and they're consistent, and there's infinitely many solutions. All right, so if you have any questions about systems, graphing systems, again, email me, ask me, and I can help you out. All right, so this ends our lesson, and have a good day.